Uh, Thanks for joining us in this 1-hour webinar, where we'll be walking through MySQL InnoDB Cluster. This is a native HA solution based on our group replication technologies. It has been in the market for over 3 years with many successful deployments, and there are a lot of interest and questions regarding this solution. So, which is the purpose why we are organizing this. So I'm going to pass the forum to Ivan, my colleague, who will walk through the solution with you. Just take note, there's a Q&A button at the bottom of the screen. If you have any questions, please feel free to post it, and we will try to address them towards the end. All right, Ivan, all yours.
Okay, good morning. This is Ivan Ma. We have the team in here, as shown on the screen: Sunny, Rolando, Timothy. They are responsible to answer your questions while I'm doing demos and talk. So feel free, if you have any questions, you don't need to wait until end of the section, and then you can submit any time. So this sections, we call this MySQL Show and Tell, and it's about InnoDB Cluster. So as Max Poon, he already telling everybody. So this is quite a #1 HA solution in MySQL. So let's get started. So this is a sections so-called show and tell. It is technical sections, around 1 hour, and mostly this is a demo sections and running through how you set up, configure, trying failover, router, and also the rolling upgrade without downtime. So we have chat window. If you have questions, you can ask something, and there is a QA button. Remember the QA button, and you can submit questions, and we will answer. Okay, right there. You don't need to wait until end of the sections, but at the end, I will keep it open, and I will answer the rest of the questions which may still be there. So the first part of this sections in 1 hour, I will try to give you a brief, very short brief about the HA, and then we'll go straight to the hands-on and the way how we set up. So high availability, meaning that we are doing redundant. Okay, the redundancy is very important. And traditionally, MySQL has been doing well with MySQL replications. The default way of doing this is asynchronous. So on the screen, pretty much you can see the redundancy of master and slave. So when there is data coming in and is written to the master server, the data will be put onto the binary log on the first machine. And this data is transported to the relay log, okay, and then get into the slave. Okay, this is kind of the process, so the slave can see the data. So for what asynchronous replications means, the data is written to the master server and it is written to the binary log, and this commit sections finish. So the data is actually resides on the local machine, and thereafter, the data is transported asynchronously from the binary logs to the relay and go into the database on slave. So the second part of replication in the journey is semi-synchronous replications. The change in here is the data is written to the binary log and at the same time is transported to relay log, and this commit sections finish. So we guarantee that the data, when it is written on the machine A, is also putting to the relay on the second machine. So this actually protects the data from, no data loss. So when the master server crash, you still can find the data on the second machine. So we are actually getting into the very latest architecture using MySQL InnoDB Cluster. This is today. So the architecture is based on replication, and the core component, which shown in the middle, it is group replication. So it's built with 3 nodes in here. So this is like the backend database server. And the applications connect to a component, we call this MySQL Router. And this router offers the transparency access to the backend group replications. So the applications via the connectors connecting to the router will transfer the data into any of the server in the group of this InnoDB cluster. And the MySQL Shell as the red box to provide the ease of use and easy to configure and check the status of this MySQL InnoDB cluster. And on the right-hand side, there is the enterprise monitor. And it also provide more graphical view and also the instant alert and notifications to the administrator and easy to use. So this is kind of a simple architecture and to give you a brief. Let's look at more details for what today I'm trying to show you on the demo. As what I said, a lot of things that we are running through is to go through the demo. So the first part is how we set up, and this is the deployment. Okay, with the setup configurations, 3 nodes. 3 nodes, I will be running 3 virtual machines. 3 virtual machines, and meaning that I have 3 IP addresses. And I will configure using the MySQL shell to create and configure this InnoDB cluster. And I will use the MySQL router and testing client to connect to this cluster. And there is a port 6446 for primary access and 6447, the port number for the secondary servers access. After that, I will operate the cluster, switching primary node from the node 1 to node 2, or node 2 back to node 1, or node 1 to node 3. And I will try to shut down or kill the server so you can see the client actually can do failover and fail back, and also recover. All this, you'll be able to see this today. And after that, I will try to do the rolling upgrade, meaning that for the first part of the demo, I will be running a lower versions of MySQL InnoDB cluster. And then I will try to upgrade the InnoDB cluster as what it is still running. It is still running. And then upgrade the server one by one without any downtimes to the client. So this is about today. So give you a break to check. If you have questions, submit the questions. We have the Q&A button. So if you have anything you want to ask, feel free to click the Q&A, and we have the team here to give you the answer. So let's get started to have some brief of my environment. Here, I hope you can see my screen. If you are not able to see the screen clear, raise your hand and tell us what actually we can help you. On the screen, there are 3 windows, one big one on the right-hand side, and the green one and the red one. So basically, the big screen, I'm trying to type something more easily that you can see. And there are the server 41, 42, and 43. Basically, if I can look at the host name, you'll be able to see that I have the 41, node 1, I have the node 2, and node 3. So basically, I ping node 1, this is from the server 1. I ping node 2 from the server VM2, ping node 3 from the another box. So 3 machines. So now I'm going to set up the database. So basically, the way is I have the path under the URL local, which I have the MySQL in the path pointing to the old version 8.0.13. The latest version as of today is 8.0.15. So I will be starting the sections, okay, with the 8013, and later on I will try to upgrade this to the latest 8015. So let's start to do this export path so that I type commands going through the MySQL path. And together with the path on MySQL shell. So I will try to do this on all this. So basically, now when I do this, I have the versions which is running 8013. Now what I do is to create the database. So I have the config folder, which I'll be seeing some configuration file. For example, my1.cnf. And this configuration is created and to put data to somewhere, the data directory, and also the base directory which the software 8013 sitting on. It is the directory in here. And the server ID is 101. So for each one, I have to get a unique number for this server ID. I enable the GTID. I make sure the table repository for replication, and I define the algorithm that we use to compare device sets. So they are pretty much similar. Okay, my1, my2, just the fact the data sit on different directory, and the server ID basically they are different, and the rest they are the same. So what I'll be doing is to create initialize the file. Sorry, I try to run it again. MySQL D. To initialize, I put this default file equals to config. Say this is the my1.cnf, and initialize insecure just the fact I try to run this without the root password, but in fact it has to. So with the 42, I will run the second one. With this, I will run the 3. So basically, I'm okay to have 3 data folder. So after that, the data folder sitting onto the 3310. So here is just created at this time. So now I'm going to start the 3 server. So the 3 server, I'm going to start with MySQL dsave, for example, and default files. Equals to config my1.cnf for this machine 1. And I'll be running this again for this, for the second one, and for this, for the third one. So basically the port number, which I just want to make sure that everybody know that this basically I'm running the root access 3310, the local host, which is here. This is 3310 port number, and this is 3320 port number. Okay, more than just the host name, but also the port number, they are different. This is just to ensure that we know that we are accessing different server, 3330. So they are running the versions of 8.0.13. So here we are running the 8.0.13. Okay, so the 3 servers right now is up and running. The 3 server is up and running. So what next? I'm going to use the MySQL shell to configure the remote admin user. So what's right now, I will try to start with the MySQL shell. Okay, so this is the MySQL shell. I'm going to run some command, which we have the DBA, and we can configure the instance with the root access, which is on this box is 3310, because the root, when it is created as the user, this is only local access. We cannot get the remote access to any server via the network. So what I'm going to do is to configure this instance with the cluster admin remote user. And I try to put a name, group replication admin, and also cluster admin password. Have to name it grpress, for example. So once I have done this, and this user is automatically created, and I need this to run on each box. Why? Because I need this to actually run on each individual box. When I click this, it's failed because there is the port numbers not 83310. Okay, the port number localhost is 20 in this box. And to this, I need to run this for the 30. And now what I do with this is I have the remote access, okay, to every box, remote access users. And to this point, I try to create the InnoDB cluster. So I can connect the gr admin, grpress, and the node 1, the port number 3310. So this is great. We have the admin users log in through the shell. And I'm going to create a cluster. So I'm trying to show you the help. So there is the help, dba.help, and we can actually do the create cluster. So if I look at this, I know how we do the configurations with some sort of the parameters. At this point, it's just simple to use. I try to create this by dba, create cluster, and give it a name. And without options at this point. So the cluster we just create and it's supposed to work in here. So the cluster is here, and I can define as this is JavaScript. You can see the point here. This is JS. I can have the SQL. I can have the Python. I can go back to JavaScript. So if I use SQL, I can run select one, select statement. I'm now running with JavaScript. I can define variable xxx equals to dba get cluster, which is the cluster objects, the instance of this variable. So with this xxx, I have different functions right here. I can check the status of the cluster at this point I just created. I've just created a cluster and it's only one node. And what next? I have to add more instance, and with the remote user grpress, and the node 2, the port number is 20. So what I'm right now is to configure this cluster with 2 nodes and adding the third one and making a 3-node cluster. And now, if I check the status again, so I have the 3 node clusters running. So at this point, we have a functional working cluster, which is pretty much very easy to use. So what next? I'm going to create the MySQL router. So the router may be on the other box. So happen I may try to run this routers on the second box, which is the green one. And let's look at this. I try to create the MySQL router. So what I do in here is to get through the folder. And what I'm doing here is there is a functions MySQL, which MySQL router, and this is actually comes with the MySQL installation. So now the MySQL router, I can bootstrap from the connection to one of the node, which may be the node 1 connecting to the node 1, gradmin, grpass, and at the point to node 1, 3310, and pointing to the directories to do the configurations on the config my router today, my router A, for example. So once I have this, when I look at this, there is my router A folder, and I can get this to start router. So I can run the start. What I do here is I have the router already started, and the port number is actually connecting to gradmin, grpass, and the host is the local host right here, and the port number 6446 as the primary server. So if I do this, I can select the host name and the port name, port number, which is the node 141 and the port number 3310. For what this actually means to me is I can do let me create a general users. Okay, what I do, I have to use this as the local host. Root 3310, I create a user demo to remote access for getting remote access, identify bar demo as for example. And then grant all the access to this demo account. And now what I do here is I can run a loop to get remote access. For example, I try to use a while loop, do, and then sleep for a while, and then having these statements using the demo users, for example, demo user, and running a select at that host name, at that port number. And you can see that it's always going to the primary server. Okay, what I'm going to do this is also can be true in here. For example, I run the MySQL router configurations for the same thing, MySQL router, bootstrap, gradmin, grpass, head, node 1, 3310, directory, config, my router, for example, B. So what I do here is my router B, I have the start command. So the same way what I'm doing in here is I can run through the query while 1 do sleep 1 and MySQL root demo pass demo host 1 2 1 and port number 6447. This is the read-only, the secondary server port number. And I'm running the same things, host name and port number. So the difference between the two here is the green one always looking for the primary server. The red screen is always looking for the secondary servers. Let me do some simple operations in here. MySQL shell, and I connect to the group admin. Let's do not giving the password and not 13310. So I'm asked for the password and connected. So again, I can get the DBA cluster and XX status. I see clear the status. And now I can switch the server. XX set primary third instance to NOC2 3320, for example. So what this means here, you see, the green ones goes to the 20 and the red ones go to 10 and 30. I can change it easily back to the 1. Okay, that will be automatic. And then the application is kind of transparent to access different server. I can do this like to the 30, just done. And you see it's quite clear. And I'm going to get back to the 1. This is wrong because the server must be the not 1. So now we have the intelligent routing for the application to transparently access the database. And what next? I'm going to shut down the server and see what happens. So I'm going to shut down the 3310. So let's see. This is connected to the 3310 server. I try to put a command shut down. So what next in here? The server, okay, 3310 is gone. So what that means here is the application has to do something, the so-called failover to another server. And the router connects to now to the 20. And the read server basically connects to the 30. So what next? I'm going to give you to look at, I need to get start the 1 again. So let me start the first server, okay, to restart it, okay? Before I restart it, let's do a check first. And I connect to the GR admin, GR path, NOC2 3320, and just to double check, get status. So now the 3310 is dead. Amazing. And this one is read-write server, and this one is read-only server. So what next? I'm trying to restart the first server. So this is kind of to restart it. And what then I will try to hook up to is to connect back to the GR admin, GR path, okay, just to get ease, okay, access without asking password. So NOC2 3320, and now let's get the status and check it again. Oh, come back and connect back to here. So likely people may want to do a switch, DBA cluster and XX. I may want to switch this back. The primary instance go back to 1. Maybe the 1 server has better memory or power. So I may want to switch it back. So you see all this we are doing is transparent, automatic, and easy to use. So what next I'm trying to do is to do the rolling upgrade. Rolling upgrade, it means the servers, they are still running as proper as what you see. They are quite okay to run. I did what I have done. Okay, so just review what I have done. I create a server, I start the server, and then I create a cluster and have all the 3 nodes joining them together and forming a 3-node cluster. And on the green and red, I put a router and they connect to the server and transparently access to the server and I did shut down and switching the primary, and the client can automatically switching to any known server with the correct status. So what the next right here is to do the upgrade, rolling upgrade. How this is possible? So let's do it this way. We have the primary servers today, and now is 3310. So what I do upgrade is to upgrade the read server first. So there's read servers, meaning that I will try to upgrade the 3.0, 2.0, and the last one 3310. Okay, so the first one, what I do here is I try to shut down the 3.0. Okay, so what I do here, shut down the 3.0, and then I try to use this. The 3.0 is here. I try to upgrade in here. So the red is 3.0, so I don't need this. So now what I need here is to bring the servers to be to a right context. So let's do it. So the right context is I log in to the 3.0 server with the super user at this point. And then I can see that select from the performance schema, there is a persisted variables. And there is a start on boot, which is on, meaning that when the servers come up, it joins the cluster automatically. So when I do this upgrade, what I need is to make sure when I restart the server, this one should not be in the cluster. So what I need is to set persist, and this cluster put on start on boot to be off. Okay, so what next is I shut down the server. Okay, shut down the server, and look at this, the status. So when I shut down the server, so this one's gone, right? Gone. And what next here is I need to do this upgrade. So what I do is I go to here, and I need to change this like the folder or base there. I should do. Okay, just make sure. Okay, so there is a folder MySQL pointing to 8013, and I will try to move this sudo move this MySQL to MySQL.o. And now what I do here is I need to link a new one, MySQL 8015. Okay, to the MySQL. Okay, why? Because if I have this, and what's right now, if I try to look at the version with the binary, this is the new binary 8015, because my path, which is pointing to the MySQL folder. Okay, there are ways that we can do different directory, but this is just a demo. I try to use a standard folder USR local MySQL. So I have already switched it, and the data is still there. But make sure that if we are doing upgrade, we're supposed to have the backup first. Okay, backup. This is the #1 important fact. But for the demo, I will go straight to do this rolling upgrade. So there is the MySQL upgrade functions, which provided by the new version. Make sure this one is running on the new version, USR local MySQL 8015 bin here. Okay, this is new version. So I can use this to connect to the server. But at this point, if I do this upgrade, I need to start the server first. So the start server, I have the MySQL D, save, and then I do the default files equals to config. This one is the #3 config. And then I start this with the new version to start with the old data. So the server supposed to start it, and then I can basically log into this server 3630. Don't do anything silly. This is the version of 8015, and this one we don't want this to connect, okay, because we asked the server to start without joining the cluster. If it joined the cluster, something wrong. This should be missing. We need to upgrade this. So what next is, the next is I do the upgrade from the new version binary and pointing to the server 3330, and this should do the upgrade on the server. So when I finish this upgrade, it means that the data directory and the system schema, or there will be some additional changes to columns, and also if there is any data formats changes, this applies to the server and data. So when I'm doing this, most important, when we do upgrade, we need to upgrade the read-only server first. Why? Because this read server, when it is upgraded, meaning the cluster, when I started, there will be two versions, the old and new version. And the new version is compatible to the old version. It can listen to the old version protocol. But if I try to upgrade the write server, the read-write server, then it may transport something new to others, and the others may not know what the new protocol is. So the server is upgraded, and what next? I want this to bring back, okay, and join the cluster. So what I do is just in similar way, set persist. Oh, wrong. I thought set persist. Let's select the performance schema dot persist variables. So there is here, I set persist to on, and now I do restart. Boom. And then look at this. And the server is getting back and recovering the data from the others. We're supposed to have more data go in. So now this is back online. So what I do next is I can start the router again in here. So I can see if I look at this demo host port 6446, and what is it? 64, and running this that host name, that port. So here it is, and the same thing while one do C1, and I have similar screen as the 42 in here. So what's right now, I need to kill this and upgrade the second one and also the third one. So the same logic, I will try to go into the server 3320, and I will do the set persist to off, not to join, and then shut it down. And shut down, it means that it's going offline. Okay, so this one's connect wrongly, and I need to connect gradmin, grpass, node 1, 3310, and variable xx equals dpa get cluster status. So here's the missing. So what next? I will be going to do the same thing with the USR local and sudo move MySQL to MySQL.o, and I need to link the MySQL 8015 to MySQL. And the MySQL, the version is right now to run on the 1.5 now. So what next here is I can go back and MySQL d save default var equals to config my 2. This is 2, the second one, CNF, and start it. And once I have started, oh, the folder is wrong. No problem. So I start it again. Now this is finished. So I can now go into the folder and point to the second one and check. So the status is 1.5 up and running, and the status is still missing, not connected. So what next area is I need to do the MySQL upgrade and pointing to the server 3320. This is the second box, upgrade. So you can see that I'm trying to finish this, the box 2, and the last one, the 3310. So upgrading the tables and schema and take a little bit while. So with this, you can see that we have options to do a lot of things. We can describe the servers, we can disconnect. If there's any problem, we can actually force the quorum to go into just 2 server set. Okay, that's finished. I can go back, and then we can now go back to the root access and set persist for the startup variable, persistent variables. So I can set persist. I just to make sure I'm not going to type this wrong. So this is easier. And then restart. Now I'm able to run this. And the second box will be coming back very soon. So now the last point is here. What I'm going to do in here is to go to the 3310 and then set persist. Hopefully set persist to off. Am I correct? To off. And then shut down. And check the 3310, and when it's shut down, and this actually coming back to the 3320 or some others. So what next? I'm going to rebuild this server and start with the same thing with USR local and sudo move mysql.o and this server. And then sudo link as MySQL 8015, the version with the MySQL. So now the versions which I'm to be running is 1.5. And with this, I'm trying to start the server again. So I'm going to start it up the server. Default file equals to config my1.cnf, and this one to start with the save, so that I can start the restart command. So when this is done, I'm pretty much I can do the upgrade. Yeah, you can go to check, but for the time, I just go straight to do the upgrade. MySQL upgrade, and then the parts I supposed to check, but this is just the same. So I'm going to upgrade the last part, and the whole family of cluster will be just rolling upgrade for all the servers, and the cluster will completely on the new version. So very soon we'll giving a upgrade the server. I hope everybody can see that clear. The rolling upgrade is quite simple, but the way is after you shut down and bring back, do not make any change to the server that may generate additional GTID, transaction ID, that will cause the clusters to break. So don't do silly things on updating any other things. So when this is actually upgraded, I can log in again and bring back the server. So you see 10, and now I need to set persist to restart it, and then restart. Okay, so now what I can see that the server has already been functional and go back to MySQL shell and say connects to gradmin, grcast, and NOC2 and 3220, and I can say execute a get cluster and the status. All servers up and running. I can go back and set primary back to the node 1 if needed. So I hope everybody happy to see this actually is working nice. Okay, so and it is upgraded version. And the last part of this demo, I want to go with a data consistency with the 8.0.15. So what that means, the 8.0.15 here is, let's look at this. I will be, what's this server? This server is, the NOC2 3320. And this is read-only server, and 5310 is the write server. And I'm going to run this with the root, for example, and 3310 as the primary. I can create a database, MyDB, and create a table, mydb.mytable, F1 integer not null primary key, and F2 Rajvar 20. So, and I can insert into mydb.mytable and values 1 AAA. So with this, I can actually see the tables from the mydb.mytable elsewhere. Okay, and there is one configuration, which means the group replication consistency. This consistency, we have the option, say, before replication consistency, okay, and one spelling. I can get this to default value, which is the default value eventual. This is default value. So we have the group replication as the session variable. Session variable, group replication consistency equal to, for example, after. So what I do here is I can insert into the mydb.mytable and values 100 my data. And this will transport the data immediately to this, okay, in synchronous mode. How do I know? For example, I flush tables with read log. If I do this again, what happened is this actually hang the way why hang, because it's trying to update the server in here, but it's just locked. So until I unlock the tables, that one will free up. So you can see that we do synchronous update to the tables and across all the ways to different way. And there is also, I can set it back. Let me set it back to default first. This is eventual to default. And if this is default, there will be the case data is not actually updated to here. Similar in here, I try to flush. And now what this means, I insert the second one. Oh, it's just finished because it's just the data is written to the relay log and finish the commit. So basically, if I look at the data in here, I still not able to see the 102 You see that 102, but this is actually still 101. Reason, because the table is locked and the apply stage is still waiting for these locks to be released. Until the way I unlock the tables, I can see clear the data is coming in. Okay, so what I can see that I can actually read the data. Okay, let's do it similarly. If I try to do this by having set consistency for the last 5 minutes, okay, I will try to complete this, set sections, replication, and consistency to equal to before. And if I try to look at the data, okay, and this one, I try to insert this, okay, I always get the latest. I always get the latest. Flash tables with logs, with read only, with logs. And then now I try to insert this, it hangs, okay, it finished, but when I select the table, it hangs. The reason is I have to apply, okay? So before I read this, I have to unlock the tables. So here is hang. The reason is there is a change here. We need to read the most updated data. Okay, the time for my demos is here. And let's get start the last two slides. So this is show and tell, and we have the monitors to visually to see clear the pictures. So this is enterprise options. There are enterprise version that we support with more visual and graph all this into the system, and we can actually back up the group replication in InnoDB cluster, online, incremental, encrypted, and more security option in there. All this actually comes to the last part, Q&A. Okay, I hope you understand the sections, and I'm going to see any questions out there. Okay, I'm able to see one questions in here. The questions is it the GR admin cluster admin must create at the database before we create the to configure the whole cluster? Okay, the answer is I need a remote admin user. Whatever the name is, GR, ABC, okay, doesn't matter. We need a remote admin users so that we can connect to the cluster. Okay, I do not suggest you use the root. Basically, the root is configure only local access. Only local access. So we need to create a remote user. So there should be a remote admin users to be created. So it is yes. Another question is coming from Jonathan. After finish upgrade from the secondary server, just proceed upgrades to main server. Yes, we need to upgrade secondary server first, and the last, okay, to upgrade the read-write server. And there's another questions coming in. Can we use 2 or more databases for replication? Okay, I would say that, can we have the InnoDB, is this a questions like InnoDB cluster, which is replicated, and can we have this InnoDB clusters to replicate to another database or MySQL? The answer is yes. I'm not sure whether this answers your questions. There are many questions bumping in. Let's wait. Can we disable this? Is there any impact on the? Now let me clear up the question first. Can we use 2 more? This one InnoDB cluster and replication to other server. to other. Okay, I tried to answer another questions by having there is the answers to database. I believe this PowerPoint can share to you. Production and DR. So the production actually a cluster and DR is the cluster. So basically InnoDB is replicate data internally, and there is actually DR, and the data will actually pass from one site to another site, and this actually goes to the router. And you can see that I go through the router. There's a reason when the server is crashed. I mean the primary server is crashed. The primary will switch to another one. With the router, we have the automatic switching, and the data is still keep moving to the DR without your notice. So this is hopefully answer your question. Sorry, I do not know the question for the disable. Sorry, can you repeat this question again? I assume all this set up for the same DC. Okay, so I have just shown the DC and DR setup. I hope you understand that for the DC and DR. Oh, there is a question is talking about MySQL export. We cannot stop the MySQL export. That is to be used. Okay, it has to cannot. Read-write router is done. The router, how's the application connecting? Okay, so for the router, you can see that the router is kind of so-called, let's look at the slide. So here is the config about the MySQL router and application, and also connects to the back box. So each application connects to the router. So there is a question about, okay, if the router is dead, so there may be a single point of failure. So here, because the router tied to the application, it means that the application is dead. So if we have multiple applications for load balancing, for example, 3 Apache or 3 Tomcat, so one is dead, it means one Tomcat is dead or one Apache is dead. So this is kind of the configurations we recommend for performance reasons and also for minimal changes. So this is kind of change. If otherwise the MySQL router is put outside the box, then you need extra like HA together with the MySQL router, because MySQL router is a standalone one software. I hope this answer your questions. And so there is a question coming from Jonathan talking about the MySQL version within the InnoDB cluster. As I have done the upgrade. So basically, you see that the upgrade means that there is old version and new version. So the new version must be read-only server, because this is kind of compatibility changes. So the new version can listen to the old version, but if the new version is the read-write server, it may actually write something to the transport layer, and the other server, the old version, may not understand. So we need to upgrade the read server first, okay, before we upgrade the read-write server. So I hope this answers your question. Okay, there is a questions coming from Fiona. Version limitations of rolling upgrade, example from 5.7 to 8.0. So it is different. It is different for 5.7 to 8.0 and 8.0 to 8.0. 5.7, it does not have the persistent variables. 5.7, it does not have persistent variables. So the way that I have shown today, it is different. Today I have shown actually using persistence variable, but with the 5.7 to do the upgrade, yes, it can actually do rolling upgrade, but the way it is different. We need to change the parameters. Okay, we need to change the parameters, okay, in the config file. So we need, yeah, I have a video on YouTube. I will show you on YouTube later on. I hope this one answer your question. And there are some more questions. Okay, so can we, there's a from the Fin, can we use MySQL replication for 2 or more database or configures for only one database? Okay, basically the InnoDB cluster is everything the same. So 3 nodes always the same. But when we talk about replication, one set of the database and the other set of the MySQL InnoDB cluster. So we can set filter, meaning that we can filter something to include, something not to include. For replication, yes, you can do filter. But for the MySQL InnoDB cluster, I believe we need all the GTID the same. So yeah, I will say that they have to be the same. And yeah, MySQL replication. We support filter. And there's a question, can we use one sensor for all cluster like Oracle RAC? So MySQL is share nothing architecture. So we don't need that. Share nothing architecture. Yes. And there's a question. Okay, good question. Is there any manual task when all nodes go down and then we come back? So there is I try to show you one more on screen here. So here the screen, the questions come in when all the nodes are down, okay? And then we bring back all the server. So when we bring back the server and the cluster is all standalone, okay, all standalone, they are not connected together. What next here is we need to connect one of the server, connect to one of the server, okay? Say MySQL shell, and then connect one of those GR admin, GR pass, for example. Okay, this is a remote admin user, and just an example. And when we do this, and all this server, okay, so they are not in cluster, you cannot get cluster, that will generate error, okay, supposed to generate error. So what we do here is there is a reboot command. You see, reboot cluster from complete outage. You just do this and it will bring back the whole cluster. I hope this one actually answer your questions. Okay, this is the manual work. Okay, to bring back the server. Manual task to bring back. So I hope this one. How come did I? So some people will actually look at the group replication. Group replication and InnoDB cluster. Okay, I recommend everybody to use InnoDB cluster. Group replication, everything is manual. Configure is manual. You shut down and boot up the sequence has to be manual, and you have to know the sequence. Okay, how you bring down the server and which server has the biggest set of the GTID, and you need to boot up the biggest set of GTID server first, and then use that to actually to start the server and connect all the rest. So this one, I believe, as what I said, you need to use the shell. That's a much better way. So tries to not to use configuration and manual work for the group replication. Okay, try to do it with the InnoDB cluster. So same from Leon. If you're using version 8, do we need manual work? Okay, So as what I said, I do not recommend good replication for manual work. Tries to use InnoDB cluster. Okay, so it's all about the questions. It is just the 12th, and I hope everybody enjoy. Okay, the talk, and thank you. So this close the section, and have a nice day. Thank you. This is to end the show and tell. Bye bye.